We will continue with our work in the chapter of the beginning of statistics, and we'll continue with working with some statistical tables and graphs. You will need to know this for your final project, so pay special attention as we go through how we construct particular tables and graphs. Okay, so let's get started. Our first type of table, which I'm sure you're familiar with, is called a frequency table. And it is just kind of like an XY chart that you might have used in an algebra class. You know, one of these guys. X on that side, Y on that side. But in statistics, we'll give him some different names. That first column, instead of calling him X, that first column is going to list the categories. And the second column is going to list the frequency that particular category occurred. So let's say I wanted to find out how many males and females were in our classroom. The category would be males and Okay, let's give it a go one more time. The categories in our first column will be males and females. And then the frequency is just how many males in the class, how many females in the class. So I don't know, there might have been 12 here and 13 there. So category is in the first column, frequency is in the second column. Sometimes we'll create a relative frequency column, and you'll do the same thing in your final project. It basically just represents a percentage. The total number of students in the class happen to be 25. So to figure out the relative frequency, we just do 12 out of 25, 13 out of 25, and that'll give us a percentage. So relative frequency is just the percentage of the total for each of those categories. And then there'll be a cumulative frequency category or column that we'll use, and I'll talk a little bit more about how that is calculated. But for now, a frequency table is pretty easy to calculate. Excuse me. Now let's talk about the different types of data we're going to come across. This data that I just put up here, the categories are qualities. It's a quality, male or female. So this is called qualitative data. So it consists of values that can be placed into non-numerical categories. Male, female is non-numerical. Quantitative data represents counts or measurements. So quantitative data, let's suppose I did a very similar survey in class, and I wanted to determine the ages of my students in class. So I set up a table. Ages are numerical. So let's just say I set my categories as, let's say 17 to 22, and then 23 to whatever, and continued binning my data like that. Figured out some frequencies. This type of data, because these categories are numerical, this would represent quantitative data. These categories are a quality, it's qualitative data. And with quantitative data, we might need to group it like I did over here. 17 through 22, grouping your data so your table will make more sense. So now let's look at an example of each. Okay, let's create some frequency tables. So we've got two examples. Let's look at the first one. We're going to consider 20 scores from a 100-point exam. So we've got the data listed. All of our scores are listed. We want to determine, we want to create our frequency table, and we want to have a relative frequency column and a cumulative frequency column. And you're going to need to do this, again, on your final project, so please make special notes. Make sure you understand how to create this. All right, so I would give you, for this problem, I would give you how to start your first category. So I'm going to say, let's start the first category to be 99 through 95. So my first category would represent scores 99 through 95. Now let's create the other ones. So the other categories, if I drop one down from 95, the next category would have the highest value of 94. That next column or that next category would go from 94 to 90. How do you know that stopping point? Well, each of these bins have to be the exact same width. They have to include the exact same number of values. So when I look at 99 to 95, it includes 95, 96, 97, 98, 99. It includes 5 units, so it's 5 units long. So when I look at this one, I need to make it 5 units long as well. So if it starts at 94, 94, 93, 92, 91, 90, it has to stop at 90. The next one's going to start at 1 down from 90, so this one will be 89. Where is 89 going to stop? Well, you'll see the pattern. It's going to stop at 95, not 95, whoops. It's going to stop at 85. The next one down is going to start with 1 less than 85, 84. Where's 84 going to stop? Well, 94 stopped at 90, 84 is going to stop at 80. So let's finish up those categories. This one's going to start at 79 and stop at 75. This one's going to start at 74 and stop at what? 70. Now you continue making these categories until you've captured all of your data. So what is my lowest value in my data set? Okay, so looking at my data, there's nothing lower than a 70. So I have captured all of my data. So what's important here, when you're setting these up, it's nice to be given what the first category has to be, because you can model everybody else off of that. These categories have to be the same width. The first one is 5 units long. The next one has to be 5 units long. And the next one starts with the next number in line. 99, 98, 97, 96, 95. So this one has to start with 94, 93, 92, 91, 90, 89, 88, and so on. So get your categories set up. Now let's find the frequency of occurrence. So let's find out how many test scores were between 99 and 95. So I'm going to come up here, and as I pick them off, I am going to mark it off. 99 through 95. There is 1. I only see 1, so my frequency is going to be 1. What about 94? Actually, I'm going to have you finish that and then come back and check your table. So pause it, work it, come back. So notice that as I used a value, I would mark it off in my data list just to make sure I used every value. And if you'll notice, 79 doesn't have a mark on him. I realized when I was done with my data, I looked back, I had not marked him off, so I had to come down here and put him in this category because I had a 6 there. When I went back and checked, oops, I missed a value. He's 7. That gives me 7 in that category. You can also check your work by seeing if your total in this frequency column totals the number of values you were working with. And here I had 20 scores, and when I total up my frequencies, it represents 20 scores. Okay, now the relative frequency column. Remember, it's the percentage, so it would be 1 over 20, figure a percentage, 2 over 20, 3 over 20, and so on. I'll pause and get those percentages. So there's the relative frequency column. So 15% of the grades were in the 89 to 85 category. 35% of the grades were in the 79 to 75 category. So it's just a percentage. Final column, cumulative frequency, accumulates the frequencies as we go down. So let me explain how that works. First frequency is going to go across 5. Okay, then I'm going to add my frequencies together as I go down. So in this next row, it's going to be the 5 plus the 10. So 5 plus the 10 would be 15%. Then I would take that 15% right here, add it to this 15%. I would have 30%. So I keep adding the next percentage in line to it. So 30 plus 15 would be 45%. 45 plus 35 would be, which is that 80%. And finally, the 80 plus the 20 should be 100%. So at the end of your cumulative frequency column, you should have 100% because all you did was accumulate all these frequencies one row at a time. So there's your first frequency distribution or frequency table. Now let's take a look at the next one. We've got 20 grades on a test. So rather than having scores, we now have grades, A, B, C, D, F. What are going to be the categories? Well, the categories will be A, B, C, D, F. Frequency. Well, I tell you what, why don't you pause it, work on that table, and then come back. So here is the frequency distribution for the grades rather than the scores. So 4 A's, 6 B's, 6 C's, 3 D's, 1 F. If I total up my frequencies, it should give me 20. That's how many scores, how many grades I was working with. Finding the percentage, I divide it by 20, the total number of scores. Frequency should total 20. If I added up my relative frequencies, that should be 100%. And remember, cumulative frequency, you bring the first relative frequency over, and then you just add 20 plus 30 is 50, 50 plus 30 is 80, 80 plus the next one is 95, 95 plus the next one is 100. What's interesting about cumulative frequencies is I can look at this 45 right there, and that tells me that 45% of my students scored between 99 and 84 because it accumulates those. 80% of my students scored between 99 and 75. Over here, I can say 80% of my students scored A, B, or C. So that last number can be helpful, that cumulative frequency can be helpful when you're looking at the overall data or maybe some trends in data. Okay, one last thing to mention about these two examples is I want you to tell me which data set represents quantitative data and which data set represents qualitative data. Going back to those two definitions, qualitative data, non-numerical categories, quantitative data, measurements or counts. And it's based on what is in your category column. So obviously here, these guys represent measures or counts. This is quantitative data. This represents a category, non-numerical. This is qualitative data. For your project, you are going to be collecting quantitative data. So your data categories have to be numerical, something you can measure. Tell you what, it is almost at 15 minutes, so I'll stop this video here and then pick up with the next one in my next video. Let me know if you have any questions.